Hi there and welcome back. I'm Cameron and I'm here to help you on your journey of learning the basics of Java. This week we'll explore some of the server-side technologies needed to create an API. Firstly, let's look at one of the basics of web technology, the HTTP protocol. HTTP stands for Hypertext Transfer Protocol. You should recognize it from the HTTP you see at the beginning of every URL. Hypertext refers to HTML code with links in it. HTTP is a standard protocol through which we interact with the internet. We make a request from a client to a specific URL with a specific HTTP method, and we receive a response from the server with whatever information is relevant and also the HTTP response code. The most common HTTP methods are GET, which is what occurs when you click on a link, and POST, which is what sends data when you submit a basic HTML form. There are other less common methods that we will cover in more depth, but most of the web traffic is made up of just these two methods. In addition to the methods which the client sends to the server, there are also responses which the server sends back to the client. There are many, but some of the most common are 200, which is sent with the most successful responses, 400, which is sent when the server thinks the client made an error, or 500 when the server had an error. Along with the response code, other data like HTML web pages is sent. A web server is an application that understands the HTTP protocol. It is responsible for serving content back to the client. Apache is the most popular web server, and we'll look at how we can use it to serve static content to users. Even though Apache is old, it is very popular and a valuable piece of technology to understand. By some estimates, it is used to host more than 50% of all websites in the world. In order to use Apache to serve files, you simply have to configure it to use a directory of your choice as its web home directory. Then all the files and folders that are copied there can be served to a client. When Apache receives a GET request for a certain file, it goes and checks if that file is located in its web directory. If it's there, then it uploads the file back to the client along with a 200 response code. If it's not there, it sends an error response code back to the client. I'm sure you have seen the famous 404 file not found error response. Apache allows for multiple websites to be hosted by the same server as well as integration with other languages like PHP, for example. Tomcat is a web server like Apache. But unlike Apache, it is specifically designed to serve dynamic content with Java. And as such, it is called a Java container. In order to use a Java container, you must compile your Java code and package it into a zip file with the extension .war, which stands for Web Archive. This package has a specific directory structure inside it and must also include a web.xml file, which specifies the location of all the Java endpoints, known as servlets. These servlets are Java methods that return HTML, but because Java code is generating the HTML, this HTML can be different depending on the user request or the current state of the server. JSPs or Java Servlet Pages are a special kind of servlet, where instead of Java code generating dynamic HTML, we have Java code or special Java tags interweaved with HTML. This makes it much easier to generate dynamic HTML, which is simpler to read and maintain. Web services differ from web pages because instead of serving up HTML content meant to be displayed in a browser, they serve up structured content like XML or JSON, which is meant to be consumed by other applications either on the back or the front end. There are two main protocols for web services. SOAP exposes application logic, allowing the logic to be called by remote systems. REST, on the other hand, exposes data as resources. Both are examples of service-oriented architecture. With SOAP, the web services are exposed as monolithic applications. However, modern web API utilities are typically small and focused microservices exposed with REST. This has many benefits. Uptime is increased because smaller parts of the application need to be stopped when being upgraded. Scalability is improved as resources may scale in the specific areas where they are needed. If you want to scale a monolithic application, you need to have many copies of the entire application. With microservices, it can just be many copies of the parts of the application that are unrestrained from the lack of resources. It also allows for more flexible development, as microservices can interact in flexible, unscripted ways. Finally, we'll introduce data persistence and look at relational databases with MySQL. We'll then build on that knowledge using the Java Persistence Framework. Storing the state of your application is vital. Databases provide a specialized way to store and retrieve your information. Relationships between different pieces of data are strictly defined and enforced, leading to referential integrity. MySQL is the most popular relational database. On top of your database, there is an application logic which allows your application to interact with the database. This is made much easier through object relational mapping provided by Hibernate and JPA. Thank you for watching. Be sure to post all your questions to the Noro forum so that we can all learn together.